Hi everyone, this is M. Pavan from Data Science Branch, IRA College. Now I am here to explain you one topic called why Java is dangerous. Today in our session, we are going to discuss about is Java dangerous or if it is dangerous, in what way it is dangerous. We will learn about this more in our slides in further. So we will move on to next slides. So this is the introduction part. So we will go through it. Spend a few days, spend a few days in a computer science or engineering or software engineering department in any university this year, and you will probably hear that Java is the next Pascal, and Java is much better teaching language than C++. Although Java's suitability for large-scale software development can be questioned, there is no doubt that it is a better teaching language than C++ in every respect. Its type safety, lack of pointers and pointers arithmetic adequacy, and emphasis on the World Wide Web all seem destined to make Java the next Pascal. I firmly believe that it would do a great disservice to the software industry if universities were to heed Wilson's advice and use Java as the first programming language. In short, I believe that to do so would be dangerous. Choosing a first language. We should provide our students with a set of core transferable programming skills that they will be able to adopt as necessary to the new programming languages that will inevitably appear during their careers. The choice of a first language in this teaching process is of critical importance. A decade ago, Pascal was widely accepted as the language of choice for such timing, for such teaching. Over time, however, Pascal became increasingly unpopular with students because it is seen purely as a teaching language. Students were only too aware that most employers used real languages like C++, and this undoubtedly led to poor motivation on Pascal courses. Why learn all the fine details of Pascal programming only to jetson it in favor of C++ in advanced courses or after graduation? As university instructors have discovered that has discovered over the last few years, it is impossible to use C++ efficiently in introductory courses. Unlike Pascal, C++ is very popular with students. Unlike C, learning to program with C++ need not involve the use of pointers until the basic material has been covered. For these reasons and others, students all over the world have been successfully taught to program using the C++ language. Of course, simply dropping Pascal in favor of C++ because it is more appealing to students is a fashion-driven approach to selecting a programming language, and without doubt, the most fashionable language this year is Java. Some argue that when developing professional programs, one of the greatest drawbacks with C++ is its flexibility. There are often many ways to achieve similar results. At a low level, this may mean deciding whether to use call by address in place of call by reference in function parameters or preprocessor macros in place of generic template functions. It might also mean deciding to use loops in place of go-to statements or a choice between global and local variables. With Java, such decisions are not a problem. For example, Java supports only call by value for primitive types and call by reference for objects. So we need to consider these things that Java is much better in flexibility and in usage in every way than compared to C++. So we will move on to next slides to learn why it is more efficient in performing than C++ and what are the main aspects of these things in further discussions. Okay, there is no support for templates or preprocessor macros. There is no explicit support for pointers, no support for goto, through it is a reversed word, and no support for global variables. Overall, these changes can help simplify professional programs and may ultimately help reduce the cost of maintaining Java code. However, rather than making Java a better teaching language than C++, these simplifications greatly reduce its worth. For example, with C++, I can use two programs to demonstrate that constant call by reference is, for large data items, more efficient than call by value. With Java, a pair of simple programs that demonstrate such concepts are infinitely more convincing than pages of general argument. With C++, I can demonstrate global variables problems using sample code that includes such a feature alongside equivalent code that does not. With Java, I can only describe the problem and argue that some other languages support global variables, a feature that should not be used. This, when teaching programming in the small with C++, I can treat my students like the adults they are, demonstrate both good and bad practice, and let them make decisions for themselves. With Java, the students and I are in straitjackets, and my ability to convincingly teach such important concept is greatly restricted. Programming in the large. Programming in the large. We will learn about this thing and we will understand why the word large is used in this Java programming. Okay. Java's major strength is that it supports only a object oriented style of program development. Objects are a recent but very important development in mainstream software development. They can be an extremely powerful tool for implementing graphical user interfaces. So much so that most agree it is a natural way to develop such systems. OO technologies are also extremely effective in developing computer simulations in medicine and other fields. Since process-oriented languages like C are inherently less complex than their OO equivalents like C++, processes-oriented designs and languages are particularly popular for this type of application. Student orientation. All students should be taught the essentials of both process-oriented and OO programming. If we accept the need to teach both, then C++ again crosses over Java. With C++, I can demonstrate process-oriented programs alongside the equivalent OO program. I can demonstrate the best way to migrate process-oriented code into an OO form, and we can discuss the value of hybrid process and object-oriented designs while we are working with code examples. None of these is practical in Java. Of course, you may argue that not everything need to be taught in the same language, especially because C++ and Java share many keywords and basic constructions. You could teach Java in introductory courses, then teach C++ in later courses. I believe this also a mistake, like it or not. At a code level, classes are based on groups of methods or member functions. It is much less confusing to teach students first how to create safe and reliable functions, then how to assemble these functions into complete classes rather than trying to teach both good class and method design simultaneously. Process first. Perhaps, however, this also makes you uncomfortable. You may feel that teaching students to write code is a process oriented style. First is a bad idea, and that it is better to encourage them to think in objects from the outset. I have some sympathy for this view. It is certainly not an easy matter to teach students over technologies after a year of process oriented techniques. However, before you adopt a pure objects first approach to programming, take another look at the textbook you propose to use on your introductory Java course. So, the OO technologies, object oriented technologies, we have to adopt those things. Have your cake and eat it. Means this is the mostly conclusion part of our session, that teaching such material in introductory courses using Java will, I believe, mean that students taught in this way develop a very poor understanding of object oriented technologies benefits. This approach works well and is popular with our students and the companies that subsequently employ them. Overall, Java is here to stay. It is powerful and in experienced hands useful as the first programming language. However, it is dangerous and should be avoided. This is the main thing we are discussed about Java, and I hope everyone understand how the way Java is more dangerous and how the way it is more useful than C++. I understand everything has good and bad, and in Java also there are good and bad. So it is very useful and it is dangerous. So I hope everyone understand my intention and get my point. So thank you for giving me this wonderful opportunity to share my little knowledge with you, and I hope everyone have a great day. Thank you all. Thank you all.